Okay, so in this video I'm going to show you guys the answers to the Google form questions I gave you for equivalent algebraic expressions and simplifying rational expressions. So the first question I'm going to answer is whether or not f of x and g of x are equivalent expressions here. So you're going to notice that f of x can be expanded and simplified. G of x doesn't really look like it can be. So first thing we're going to do is we're going to expand and simplify out f of x to see what we get. So to do that, I have three binomials that I'm multiplying by. Now I could multiply the first two and then finally multiply by the last one, but typically I like to multiply the last two before multiplying by the first one. So I'm going to leave the x minus 3 and I'm going to multiply x plus 2 times x plus 5, and by doing that I get x squared plus 5x plus 2x plus 10. Okay, you notice I have 5x plus 2x there, so that's going to simplify into x minus 3 times x squared plus 7x plus 10. And now I'm multiplying a binomial by a trinomial, and it works exactly the same way. I multiply x by each term in the trinomial, and then I multiply negative 3 by each term in the trinomial. So we're going to get, so x times x squared is x cubed, x times plus 7x is plus 7x squared, x times plus 10 is plus 10x, and then I move on to the minus 3. So negative 3 times x squared is negative 3x squared, negative 3 times 7x is negative 21x, and then negative 3 times 10 is minus 30. And again, we have some like terms. So x cubed looks like the only cubic term there, so we're going to have x cubed, 7x squared minus 3x squared is 4x squared, 10x minus 21x is negative 11x, and then we have the negative 30 on its own. So notice that that is actually the same thing as g of x, so that's equal to g of x, and therefore we can say that f of x equals g of x. All right, for the second question, that's our rational expressions, or sorry, yeah, simplifying rational expressions questions. So we had x squared plus 11x plus 30 over x plus 6, and we needed to simplify this. So the first step is to factor everything that we can in the numerator and the denominator. Okay, so the numerator is factorable, the denominator really isn't. So we're gonna factor the numerator, and it's gonna factor into x plus 5 times x plus 6, and since the denominator is not factorable, we're just gonna write it as x plus 6 on the bottom. Now, here's the thing. Since the bottom is not factorable, what that means is that we can treat it as though it is in itself like an entire factor. It's a factor in and of itself. So I'm going to put little brackets around there just to show that. So that bottom x plus 6 is a factor, right? And since it is a factor, that means we can actually cancel that x plus 6 with the one that's up top, right? And that leaves me with nothing on the bottom. So the denominator is basically just going to be 1. It's going to be x plus 5 over 1 is what we get. But I don't really need to write the denominator anymore. I'm just going to write that as x plus 5. Okay. Now the only other thing we need to know is the restrictions. So the restrictions. So what we're going to do is we need to decide. Okay, we need to make sure that that x plus 5 is equal to the expression up above, and to do that we need to make sure that they have the same restrictions. So we're going to look at the restrictions of our original expression, right, which are easily viewable from this this middle line here when everything has been factored already, and we want to make sure that our denominator is not equal to 0. So the only x value that would make our denominator equal to 0 is x equals negative 6. So we say that x is not equal to negative 6 because of that bottom term there. Okay, guys, take care.